Hello class, I'm going to finish page 2 now of our 13-3 notes. Alright, so now we need to take and convert from radians to degrees, practicing this skill again. Remember our conversion factor is either pi over 180 or 180 over pi. You know which one to pick because you want the pi to cancel out to convert into degrees. 180 gets divided by 2 to make 90 degrees. For this next question, you're going to take the degrees, and now I want degrees to cancel, so I put that in the denominator. If it turns out that I'm going too fast for you here, what you need to do is rewind, okay? Because the last video took me a really long time to download. The way that I got 5 pi over 4 is to take and divide these both by 75, but if you don't recognize 75 as the greatest common factor, you could divide by 5, and then by 5 again, and then by 3, or you could just simply use the reducing function on your calculator. All right, this next one is 2 radians. It doesn't have any pi in it, but we still want pi to cancel out. So we're going to put pi in the denominator. We want the answer to be in degrees. So now I'm going to switch to my calculator, and this one is okay to answer as a decimal. You're going to get 114.6 degrees. And last one, 150 degrees gets converted into radians by multiplying by pi over 180. Remember, this is our conversion factor. I can cancel out these zeros, kind of like dividing by 10. And 15 and 18 are both divisible by 3, giving me 5 pi over 6. Unit here is radians. Okay, for this next series of problems, what I have to do is use my unit circle. I gave you a copy of this before you left, but if you happen to have lost it, I can put another attachment in the file and you can just download it again. We want the cosine and the sine of pi over 4. I'm going to locate pi over 4 in quadrant 1. That actually corresponds to a 45-degree angle, and the sine and cosine are both root 2 over 2. Remember, the cosine is the x and the sine is the y. Again, remember the cosine is the x and the sine is the y. That's the rule. That's a very important rule when you're working with a unit circle. And then this next one, we want 7 pi over 6. We'll locate 7 pi over 6 in quadrant 3. You can see that the x value, again, the cosine is negative root 3 over 2, and the sine is 1/2. So the cosine is negative root 3 over 2, and the sine is negative 1/2. All right, this next thing is just a formula. It's very basic. It's plug and chug. I'm going to write it a little bit bigger since it's kind of hard to read here. And the formula says S, which stands for the arc length, is equal to R, which stands for the radius of the circle, the distance from the center to the outside, times theta. Again, this R is for radius, and this is for the angle, but it must be in the unit of radians. Okay, so here, this problem 3, I'm going to take and look at this circle and look at S, which is this arc right here. See that the radius is 3 and the radians is 5 pi over 6. So I'm just going to plug and chug into the formula R times theta. If this 5 pi over 6 were given in the unit of degrees, I'd have to convert it. We know from our problem up above, part D, that it's going to equal 150 degrees. You can type this in your calculator because it says to round to the nearest tenth, and this is going to give us 7.9 inches. And then this next problem right here, I'm going to use the space down below because there's really not a lot here. So I'm going to find this part by using this radians, and again, still the radius is 3. And again, this is just plug and chug. Type this in your calculator, and for this one you get 6.3. Units is just a linear quantity. The arc length is just how long it is from here to there. Okay, so I hope that made sense. If you have any questions, please email me. Have a good day. Hope you're behaving yourself. Be good for your parents. Stay safe and healthy.